Okay, so we are going to translate PC relative instructions, that is register to memory. So for that, we'll directly come to the example so that you can understand that. Okay. So you have seen this program earlier itself. Well, program this instruction under the first on line number 10. On line number 10, if you see, you have an instruction which says first STL RETADR. So ഇവിടെ നമ്മൾ use ചെയ്തിട്ട് what have we used? We have used RETADR, okay? And this is actually a label. This is a label which has got an address of 0030. Okay, which has got an address of 0030. ഞാൻ പഠിപ്പിച്ചപ്പോൾ തന്നെ തുടക്കത്തിലെ ഞാൻ പറഞ്ഞു why we are studying all this, why program counter relative addressing, ഇതൊക്കെ നമ്മൾ എന്തിനാ പഠിക്കണം? നമുക്കിപ്പോൾ നമ്മളെ കമ്പ്യൂട്ടറിൽ whatever is there, if you have to run any program segment or any program that we have to run, it has to be brought into the main memory. And ഞാൻ നിങ്ങളുടെ അടുത്ത് പറഞ്ഞു നമുക്ക് സ്ഥലം എവിടെ ഉണ്ട് അവിടെ മാത്രമേ ഈ പ്രോഗ്രാമിന് നമുക്ക് ലോഡ് ചെയ്യാൻ പറ്റത്തുള്ളൂ. So that is why നമ്മൾ പ്രോഗ്രാം എഴുതുമ്പോൾ by default we started from 00 വെച്ചാണ് നമ്മൾ സ്റ്റാർട്ട് ചെയ്തിട്ടുള്ളത്. But നമ്മൾ ലോഡ് ചെയ്യുമ്പോൾ it is not required that the starting address has to be 1000. It can be anywhere. It can be 5000, it can be 3000, it can be 2000, it can be 1000. So നമ്മളുടെ പ്രോഗ്രാം അതിൻ്റെ അനുസരിച്ചുമാണ്. That is the starting value, instead of being 000, it has to be 100. Okay, and corresponding to that, all the other values will also have to change. ചില ഇൻസ്ട്രക്ഷൻസിലെ ഈ നമ്മുടെ ലൊക്കേഷൻ കൗണ്ടർ വാല്യൂ മാറിയാലും it doesn't make any difference. But there are instructions where if the location counter value if it changes, it will reflect in your object code. അത് പറയുമ്പോൾ അത് കാണിക്കാൻ വേണ്ടിയാണ് ഒരു എക്സാമ്പിൾ എടുക്കുന്നത്. That is, you have this particular instruction where you have RETADR, return address, and this return address is a label which has got an address. That address is said to be totally dependent upon your location counter. So in this case, your location counter value is 0030. It is said to be 0030. So in the location counter, if 000 vachu thodangiyonde, it is fine. But had it been 1000 or had it been starting from 2000 location, ഈ program ആ ഒരു particular location നിന്ന് തുടങ്ങിയിരുന്നെങ്കിൽ obviously this value won't have been 0030, isn't it? It would have been different. It would have been 1030. You can presume like that. അപ്പോൾ അങ്ങനെ വരുമ്പോൾ നമുക്ക് ഈ ഒബ്ജക്റ്റ് കോഡ് ജനറേറ്റ് ചെയ്യുമ്പോൾ ഓരോ പ്രാവശ്യം നമ്മൾ എവിടെയാണ് നമ്മളെ പ്രോഗ്രാമിനെ മെമ്മറിയിൽ ലോഡ് ചെയ്യണം അതിൻ്റെ അനുസരിച്ച് വേണം ഈ RETADRന്റെ വാല്യൂ നമ്മൾ റീപ്ലേസ് ചെയ്ത് കൊടുക്കേണ്ടത്. So how do we do it? SIC ലോക്കെ അങ്ങനെ പ്രശ്നമില്ല, but SIC bar XCയിൽ now we are going to see how we are going to see it. Now to do this, what you have to say is നമ്മൾ എപ്പോഴും പ്രോഗ്രാം കൗണ്ടറിൻ്റെ നമ്മളുടെ സ്പെഷ്യാലിറ്റി എന്താണ്? What is the specialty of your program counter? നമ്മളിപ്പോൾ പ്രോഗ്രാം കൗണ്ടറിൽ ഇനീഷ്യലി 000 പറഞ്ഞൊരു അഡ്രസ്സ് നമ്മൾ എടുത്ത് വയ്ക്കും. ആ ഒരു അഡ്രസ്സ് എടുത്ത് വയ്ക്കുമ്പോൾ ഇറ്റ് സെസ് ദാറ്റ് ആ ഒരു പെർട്ടിക്കുലർ അഡ്രസ്സിലുള്ള ഇൻസ്ട്രക്ഷൻ ആണ് നമ്മൾ മെമ്മറിയിൽ നിന്ന് ഫെച്ച് ചെയ്തിട്ട് നമ്മൾ എന്താ ചെയ്യണേ, വി ആർ ഗോയിങ് ടു മെമ്മറി ഫെച്ച് ചെയ്തിട്ട് മെമ്മറിയുടെ കൂടെ ബാക്കി അതിൻ്റെ വാട്ട് ഇസ് ദാറ്റ് ഇൻസ്ട്രക്ഷൻ അതിൻ്റെ എക്സിക്യൂഷൻ അതിനെ ഡീകോഡ് ചെയ്തിട്ട് എക്സിക്യൂട്ട് ചെയ്യാൻ വേണ്ടി നമ്മൾ ചെയ്യും. So once it has fetched the instruction from this location, the program counter will be updated to the next location. And the next location here is said to be what? It is said to be 003. Okay, the next location is said to be 003. That is, even though we will be executing this particular instruction, that is STL return address, your instruction nammal execute cheyidondirikkanam. Even if we are executing this instruction, what is happening is our program counter is updated as 0003. Now program counter is updated as 0003. അങ്ങനെയാണ് നമ്മൾ program counterനെ നമ്മൾ increment ചെയ്ത് വയ്ക്കും. Okay, that is always so that it can fetch the next instruction on the basis of this address. Okay, this you must have studied earlier. So that is about your program counter. So what we were saying is RETADRന്റെ അഡ്രസ് നമുക്ക് എങ്ങനെ, how can we relocate ചെയ്യുമ്പോൾ നമുക്ക് എങ്ങനെ ഈ ഒരു വാല്യൂ നമുക്ക് കണ്ടുപിടിക്കാൻ പറ്റും? So where is it located? It is said to be located at location that is said to be 0030. Okay, and എൻ്റെ program counterൽ ഇപ്പോഴത്തെ വാല്യൂ എന്താണ്? It is said to be 0003. So what is the difference between these two values? ആ വാല്യൂ ആണ് നമ്മൾ കണ്ടുപിടിച്ച് വയ്ക്കേണ്ടത്. So that displacement, that difference in the value is said to be called as the displacement. What is it called? It is said to be called as the displacement. So whenever you have a label in your instruction, okay, in the operand side, and whenever you relocate a program, you have to see that by what value you have to displace your program counter or your location counter such that you will get the value of that particular label. ഈ ലേബിളിന്റെ അഡ്രസ് കിട്ടാൻ വേണ്ടി ഞാൻ എത്രമാത്രം ഡിസ്പ്ലേസ്മെന്റ് ചെയ്താൽ എനിക്ക് ഈ ഒരു അഡ്രസ് എനിക്ക് കിട്ടാൻ പറ്റത്തുള്ളൂ. So I have to find what is the displacement. You're not going to check the displacement from the location chord 0. You're going to check it from 0003. Why do you start from 0003? It is always program counter or instruction fetch ചെയ്ത് കഴിഞ്ഞാൽ അത് ഓട്ടോമാറ്റിക് ആയിട്ട് അടുത്ത അഡ്രസ്സിലോട്ട് അത് അപ്ഡേറ്റ് ആയിരിക്കും. Even though I am executing this instruction, my program counter will have the value, the location counter of the next instruction. So displacement has to be found between 003 and the address of RET ADR, which is said to be 0030. So that is what I have to find the displacement. Now how do I find the displacement? That means I have to take the difference between the two. Minus ചെയ്താലല്ലേ എനിക്ക് difference കിട്ടാൻ പറ്റത്തുള്ളൂ. That is, I'll have to do 30 minus 3. Okay, so what is the answer? Now you have to remember 30 is in hexadecimal and 3 is also in hexadecimal. 30 is in hexadecimal and 3 is also in your hexadecimal value. So how do you convert hexadecimal to the value 10, and how do you convert this 3 to the value 10? Why do we do it like this? Why conversion is required like this? It is basically നമുക്ക് subtraction എളുപ്പത്തിൽ ചെയ്യാൻ വേണ്ടിയാണ് നമ്മൾ ഇങ്ങനത്തെ ഒരു കാര്യം ചെയ്യണം. So I have taken 30 to the base 16 and I have to convert it to the base 10. So how do I do it? Anybody has any idea? How do we do it? Whenever we have a hexadecimal value, you remember we have a hexadecimal value that is said to be called as 30. Okay, I've got 30. So I'll write it as 30. So this has the base 16 raised to 0. This has not divided by, we take the, whenever we have to convert from base 10 to base 16, we do division by 16. And whenever we have from base 16 to base 10, you have to take the weights, positional weights vachittu multiply cheyidu kodukkanam. So 0 has got a positional weight of 16 raised to 0 and 3 has got a weightage of 16 raised to 1. So if you see this, you can actually write it as 3 into 16 raised to 1 plus 0 into 16 raised to 0. The 16 raised to 0 is actually 1, and as it is multiplied with 0, this term has no significance there. And if you remember, what is your 16 into 3? You get it as 48. So 48 plus 0, you will get the value as 48. So your 30 is 30 in the base 16 is actually converted to 48 to the base 10. Now next is 3. What about 3? What about 3? You know, 3 case നമുക്ക് അറിയാം 3 16 ലായാലും base 10 ലായാലും same ആണ്. So if I take 3, if the positional weight is 16 raised to 0, it is actually 3 into 16 raised to 0, which is actually 3 into 1. You get the value same, that is said to be 3. So I got here 3 and I got here 48. Now I need to do my subtraction 48 minus 3. So what do I get? 48 minus 3, don't I get it as 45? Don't I get it as 45? Okay, this 45 is to the base 10, but address le eduthumo you have to always remember, you can't write it to the base 10. You have to convert it to the base 16, and in this case from base 10 to base 16, like Abhishek had said, you will have to divide it by 16. So 45 then namma 16 vachu divide cheyyumbom, what do you get the answer as? What do you get? You get 16 to 32, and 32 ne namukku 45 ne minus cheyyumbom we'll get the remainder as 13. And what is this 13? Actually, this 13 is actually equal to D in hexadecimal. So you get the value as equal to 2D. Did you understand the value 2D? How we get the 2D? 2D is the displacement between these two values. 2D is the displacement between these two values. 2D is the displacement between these two values. So I'll clear the location to make things more easier. Okay, so I have obviously ഇത് ഏത് ഫോമാറ്റ് ആണ്, പ്ലസ് സൈൻ ഇല്ലാത്തതുകൊണ്ട് എല്ലാം ഫോമാറ്റ് 3 ആയിരിക്കും. So format 3, you know what the format is, and when you write the format also, when you ask to write formats, please write it like this. Okay, that is the first 6 bits are said to be for your opcode, then the next 6 bits is for your flag, and the last 12 bits is for your displacement. Okay, so 6 bits la namkippam in the case of your instruction, that is STL. Okay, STL if you see at the back of your text in the appendix, you will find that the opcode value is set to be 14. The opcode value is set to be 14. So I'll just write the bits 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is N, I, X, B, P, E. And then my obviously 4, 4, and the remaining 4. So this is 1, this is 2, and this is set to be 3. So I've got 3 here. Displacement 2D and displacement and you know the value of your D is actually what? 13. 13 it is 1 1. 12 is 1 1 0 0. So 13 number 1 1 0 1. That's how you remember. So 1 1 0 1 and 2 is 0 0 1 0. And then this I have nothing, so I'll put it as 0. My format is E is set to be my format, and as I'm using the format 3, it is going to have a value 0. I'm using a program counter relative, that is difference difference the program counter relative and I'll give it as 1. Okay, so that is there. I'll stop there. And then I've got the opcode as 14. 14 means 1 and 4, isn't it? 1 is set to be represent 0 0 0 1 and 4 is set to be represent 0 1 0 0. Okay, 3 could I know I'm not using index register. I use base register use. So they are set to be all put as 0. But I already mentioned to you that when you are using a displacement, that means you're not using an indirect immediate addressing and indirect addressing. You will have the values as 1. If the values and 0 0 1 because we immediate addressing use and we are also not using what indirect addressing. Indirect addressing this if you see here this symbol shows that indirect addressing symbol is there a symbol like that here? We don't have it there. So we can say that you can write it always in this particular form. So what is the answer? I start grouping as 4 bits, isn't it? We should always do it from LSB position. Either 4, then we have the 4 bits, then we have the next 4 bits, then we have the next 4 bits, and then we have the next 4 bits, and like this. So 1 1 0 1, you know it is set to be 3. This is going to be 2. This is going to be 0. What is 0 0 1 0? It is going to be 2 for me, isn't it? Then we are set to be having what? 0 1 1 1. That stands for 7. And then the final one is set to be 1. So your object code for this particular instruction, is 17202D. Okay, I'm sorry. This is 13 actually. And this is 13 and this 13 is said to be written as D. So you get it as 17202D. I hope you have understood how to generate the opcode for an instruction where the operand is something which is, the operand value is something which depends upon the location counter value. Okay, it depends on the location counter value because other in the Varna, RET ADR is a label and its value is always determined by what the value of location counter is. That is why we had to do such kind of calculations. Okay, so we are going to take another example to show the same thing, program relative and a concept. Now take the line number 14. Okay, if you consider the line number 4040, which says that JC loop. Okay, we have JC loop. Okay, so this jump in the opcode. I already said you will get it from the back of your text. It is said to be given as 3C. Okay, now what about C loop? C loop is actually a label, isn't it? Variable side label program label in the field C loop in the value it is here. It is like something which is before it, isn't it? Value and what is the location counter value for that? The location counter value, you can say it is set to be 006. It is set to be 006. But in the program counter value it had taken 0017 instruction fetch and instruction baki jodi CPU allocate but then it will be at the same time it will be incremented to a new value that is said to be called as 0018. That is said to be called as 0018. So I need to find what is the displacement between these two values. I need to find what is the displacement between 0006 and this 001A. Okay, 006 and 001A. Now how do I do this? Again, the values are set to be what? The values are set to be in hexadecimal, isn't it? So I'll have to convert it into which form? I'll have to first convert it in my decimal form. To convert into decimal form, I know 1a എന്ന് പറഞ്ഞാൽ obviously a stands for 10. So the base, the weightage of that place is said to be a weightage is 16 raised to 0. This is 16 raised to 1. So I can write as 1 into 16 raised to 1 plus 10 into 16 raised to 0. You know this is going to be 16 and this is going to be 10. So this gives me some value as 26. I've got my 26. Now what about your 6? Obviously 6 thanne aayirikkum. Even if you put the weight and see, that is 6 into 16 raised to 0, which will come as 16 into 1. So you get it as 6. So I've got here the value 6 and I've got the value as 26. So when I do 6 minus 26, okay, because forward it is a backward referencing that we are doing, because ഇവിടെ ഇരിക്കുന്ന C loop എന്ന് പറഞ്ഞാൽ നമ്മൾ നേരത്തെ കണ്ട ഒരു C loopന്റെ value. That is why this negative value comes. So when you take this difference, what do you get? You get the value as, what do you get the value? You get as minus 20. What is the value that you get? You get as minus 20. But this minus 20 എനിക്ക് ഡയറക്റ്റ് ആയിട്ട് എഴുതാൻ പറ്റോ? ഇല്ല. ഈ 20 എന്ന് പറഞ്ഞാൽ ഏതാണ്? It is to the base 10. So I need to convert it into the base 16. So how to convert into base 16? 20 I will have to divide by 16. So 16 ones are 16 and the balance is set to be 4. So I take it like this. So my answer is set to be minus 14 to the base 16. There is a negative sign coming in. There is a negative sign coming in. I'll just write it here. Minus 14 to the base 16. Okay, I don't have space, so I'm going to erase all. So I had my instruction, if I remember, it was J C loop, and I already said J had a value of 3C, okay, and C loop in the displacement njan kandudichu, it was something like it was equal to minus of 14 to the base 16 again. Minus value nu vendi if I have a minus value in my displacement coming up, I have to remember that I'll have to take the 2's complement representation. I'll use the 2's complement representation. You remember how 2's complement representation of a number is minus 14 to the base 16 in there. If I have to represent this in my binary form, first I'll write what is plus 14. Okay, and displacement in the format 3 la. Please remember displacement in format 3. Etra bits are displacement 12 bits are. So this displacement value has to come here, right? So namukku etra bits undu 12 bits. So I'll represent my 14 using 12 bits. That is 1 2 3 4 1 2 3 4 1 2 3 4. So 4 3s are 12. Okay. Now once that is done, now next is 14. 14 ne enikku engane represent cheyan pattum? What is the value for my 14? What is the value for my 14? Anybody? It is 1 4, isn't it? It is said to be 1 4. So I'll write it as 0 0 0 1, and 4 is said to be written as 0 1 0 0. Remaining portion I'm going to put as 0, that is plus 14. Then I find what's the 1's complement. I get 1 1 1, I get 1 1 1 0, then I get 1 0 1 1. I have to find plus 1 to get my 2's complement. So plus 1 I'll do. So I'll get it as 0. I'll get 0 here, I'll get 1 here, I'll get 1. Remaining will be same, isn't it? Remaining is going to be same, because this 1 is going to affect only these two. 1 plus 1 is said to be 0. 1 ഇവിടെ വരും, 1 plus 1 0. 1 1 ഇവിടെ വന്നു, പിന്നെ ബാക്കിയെല്ലാം അതേപോലെ I can write. So I've got this value. You know what this 4 ones are. It represents F. What is this? This is actually my E, isn't it? And what is this? Actually, this is the value 12. And if you remember, 10, 11, 12, 10 is A, this is B, and this is C, isn't it? So instead of writing 12, I write it as C. I'll write it as C. So my displacement is actually what? I got my displacement value as FEC. My displacement value as FEC. Okay. Keeping all that in mind, now I'm going to write my instruction. That is, I've got JC loop. Okay. And within the displacement NKFEC negative. And even the value I had got it as 3C. So my instruction format Nokuma 1, 2, 3, 4, 5, 6. That is my opcode. Then I have NIXDPE, NIXDPE, and then I have my 4 bits that already I found out. Okay, ഇത് ഞാൻ വാല്യൂ നേരത്തെ കണ്ടുപിടിച്ചില്ലേ, അതാണ് ഞാൻ ഇവിടെ എഴുതിയത്. That is, it was F, E and C, isn't it? I got it as C. This was the value that I had got. I got it as F, E, C. അത് ഞാൻ കണ്ടുപിടിച്ചു. ഇനി ബാക്കി പോർഷൻസ് നോക്കണം. ഫോർമാറ്റ് 3 ആൻഡ് ഇയുടെ വാല്യൂ 0. Program counter, yes, as I'm finding the difference between this particular value and this particular value. So obviously program counter relative ആണ്. So I'll put as 1. Base relative അല്ല, നമ്മൾ ഇൻഡെക്സ് രജിസ്റ്റർ നമ്മളിവിടെ യൂസ് ചെയ്തിട്ടില്ല. ഇമ്മീഡിയറ്റ് അഡ്രസ്സിങ്ങും അല്ല, ആൻഡ് പിന്നെ indirect addressing varnilla, so it is all set to be zeros. That's what I've put it as zeros, isn't it? So is it zeros, children? You're not supposed to put 0, you're supposed to put 1. What about my op code? It is 3C. 3 parna 0 0 1 1, it is 0 0 1 1. C and the varayamam, what is the value of C? We just saw it is set to be 1 1 0 0. It is 1 1 0 0. But I said we are not using indirect immediate addressing, we are not using indirect addressing. So the value of my n and I has to be 1. N and I has to be 1. So namukku kitnathu ingathe case aanu. So here we have already decoded and written this is F, this is E and this is C. Now what about these 4 bits? It is said to be 2. Okay. What about these 4 bits? It is said to be coming up to F. And what about this? This comes to 3. So I can write the object code as 3F2FEC. So do I get the same code? Object code in the corresponding, okay, 3F2FEC. Yes, we have got the answer. So we had studied about how to do for program counter relative namukku engane adinte object code generate cheyyam vendi pattum. That's what we saw. Next we are going to see how about the immediate addressing. Ini namukku nokkandathu immediate addressing. What do you mean by immediate addressing? That is, ഞാൻ യൂസ് ചെയ്യുന്ന വാല്യൂ ഡയറക്റ്റ് ആയിട്ട് തന്നെ എൻ്റെ ഇൻസ്ട്രക്ഷനിൽ അവൈലബിൾ ഉണ്ട്. ഇത് കാണുമ്പോൾ തന്നെ യു ക്യാൻ സീ ദറ്റ് ദിസ് ഇൻസ്ട്രക്ഷൻ wherever hash comes you have to remember, like #0, #length, #3, like that we have a lot of them. Okay, so we are going to take the first example, that is here LDA #3, that is in line number 55. So ഇങ്ങനത്തെ ഒരു ഇൻസ്ട്രക്ഷൻ കണ്ടു കഴിഞ്ഞാൽ അതിൻ്റെ ഓബ്ജക്ട് കോഡ് നമുക്ക് എങ്ങനെ ജനറേറ്റ് ചെയ്യാൻ പറ്റും? How are we going to generate the object code for such an instruction? So I have written the instruction LDA and #3, and from the very beginning I've been telling it the code എപ്പോഴും എന്തായിരിക്കും 0 0 ആണ്. And hash എന്ന് പറഞ്ഞാൽ അതിൻ്റെ അർത്ഥം എന്താണ്? The immediate, you are going to use immediate addressing, so I has to be equal to 1. Okay, and 3 എന്ന് പറഞ്ഞാൽ obviously the value 3. This നമ്മൾ നോക്കിയാലും hexadecimal also has the value 3 itself. 3യുടെ hexadecimal value എന്താണ്? Base 10 ആണെങ്കിലും here it is always given in base 10. You convert it to the base 16, it is 3 only. So how do I write for this? So when I write for this, I know it is going to be format 3. So in my format 3, how do I have? Format 3, I'll have 1, 2, 3, 4, 5, 6 for my opcode. NIXBPE. Okay, NIXBPE. Then I have 12 bits for my displacement, 1, 2, 3, 4, 1, 2, 3, 4. So value 3 tannittundu, so 0, 0, 1, 1. Baki all positions are going to be 0, 0, 0, 0, 0, 0. Okay, that's how I got it. And then I have format 3 thanne use cheyana because plus sign allathondo ivida plus illathondo ende format 3 thanne aayirikkum. So the e value is 0. Am I using program relative? No. Am I using base register? No. Am I using index register? No. Am I using immediate addressing? Yes. 3 the value direct ആയിട്ട് തന്നെ instruction provide ചെയ്തിട്ടുണ്ട്. Yes. So I is 1 and n is set to be 0. Actually this നമുക്ക് പിന്നെ ചെയ്യാമായിരുന്നു. After writing the code for LDA. LDA code എന്തായാലും 0 0 ആണ്. അപ്പോൾ അത് എന്തായാലും first 4 bits 0. The next 4 bits are also supposed to be 0. But നമ്മളിവിടെ immediate addressing യൂസ് ചെയ്യുന്നുണ്ട്. ഈ I ബിറ്റിനെ നമ്മൾ മാറ്റി 1 ആക്കും. I bit will be changed to 1. Now if you start looking into your object code, this will be 0, this is set to be 0, this is set to be 3. What about this? This is also going to be 0. Now ivide nokkumbam it is 0 0 0 1, so this is going to be 1 and this is going to be 0. So I get it as 0 1 0 0 0 3. This is my object code. Am I correct? I get it like this. It is 0 1 0 0 0 3. I hope you have understood how we get that. Now we'll take another example. Now the difference between these two is ഇവിടെ accumulator use ചെയ്തത്, ഇവിടെ register T use ചെയ്തത്. So obviously their code will differ. ഇവിടെ the code 00 ആയിരുന്നു. ടെക്സ്റ്റിന്റെ ബാക്കിൽ നോക്കിയാൽ LDTയുടെ code is said to be coming to 1 minute. LDT has got, it is written there, I didn't notice it, I'm sorry. So LDT has a value which is said to be 74. Okay, it is said to be 74. And then this value that you have 4096, please remember 4096 is to the base 10. You need to convert this to the base 16. You need to convert this to the base 16. So how do you convert this to the base 16? You must be remembering, you have to divide 4096 by 16. So I had done the calculation earlier itself. So on that basis, I'll be saying this 256 and the remainder is 0. Again, I can divide by 16, I'll get the remainder 0, and the 16 is said to be 16 1 the 16 is said to be 0. So if I take my value like this, I get the values 1000 to the base 16. Okay, so 4096 into the base 10 is represented as 100 to the base 16. This is how we do it. So I've got it in this particular form. Now what you have to remember is, ini namukku e value kitti. Ini enakku instruction engane ezhudam. Instruction ezhuduma opcode, that is 6 bits. Okay, 1 2 3 4 5 6. NIX BPE. Ezhudi practice cheyanam. So when you practice it like this, you will remember. And then you have obviously your 12 bits for your opcode that you have. And they are not opcode, it is for your displacement. Okay, so let's start filling in. Eniki 4096 in the value and the get 1000. So last is 0000. Then I have. Okay, so one thing that we didn't check is it is plus sign. So when it is plus sign, how many bits I'm going to have in my which format I'm going to use? I'm going to use the format 4. I'm going to use format 4. What is format 4? 6 bits for your opcode, 6 bits for your flag, and 20 bits for your instruction, isn't it? Whatever it is, your instruction will be taking, it is going to take your 20 bits. So the address is going to take 20 bits. So here I had given NIX BPE, so I must have one more 4 bits. So then 0000. So 4 again 0000, and then 1000. So I've written 1000. That's what I've written. My address I have given. Now next is I'm using the format. I'm making use of the format. Which format I'm using? The 4th format. So that's why my E value has to be 1. Okay. What about my 74? 74 is like 0. I have the value of 7 is 1 1 1, and 4 is said to be 0 1 0 0. I do not use index register, I do not use base register, I'm not using program counter also, so all zeros. But I know that I am using a hash value. The moment I use a hash value, I have to remember what should be my I. What should be my I? So my I value is going to be, I'm using an immediate addressing. So it has to be what? It has to have a value of 0. And I hope you have understood what we have done here. We have just simply grouped it, and when we group it, we get it as, when we group it, what do we get? We get it as this, the address part, we get it as 01000, and as your E is set to be 1, as we are making use of format 4, plus sign കാണുമ്പം E യുടെ value 1 ഇട്ടോളാം, hash sign കാണുമ്പം I യുടെ value 1 ഇട്ടോളാം, ബാക്കി all accordingly, that is LDT യുടെ value എന്താണ് 74. So when we wrote that, it is interfering in my N and I, but I value will be equal to 1. Okay, I value will be equal to 1. Why it is equal to 1? Because I see a hash symbol, that is immediate addressing is being used. So when I start grouping my bits from the lower LSB position, I get the answer is 7510100. I hope this is clear with everyone. We need to be very, very careful when we do such things. You can see that how small mistake, the whole thing goes wrong. Now, the another one that we have to deal with is the indirect addressing. The another one that we have to deal with indirect addressing. How do you know it is indirect addressing? By seeing the symbol at the rate. By seeing the symbol at the rate. Okay. So we'll take the example in line number 70. Okay, in line number 70, we have the instruction that is J, and it has the @ symbol, which shows that we are going to use indirect addressing. And what is this? This is the location, that is return address. So what do you mean by indirect addressing? Indirect addressing in the sense, നമ്മളിപ്പം RETD ADR കിടക്കുന്ന value, that is RET ADR is where it is said to be in 0030, okay, and അതിൽ നമ്മൾ എന്താ ചെയ്യണേ, we are going to add a value to it. We are going to add a value to it, and on that basis we are going to jump to that particular location. We are going to jump to that particular location. Now how do we do this? I'm going to continue with this, how it is going to work. Let us see. So I have got J, I've got J @ okay, RETADR, okay, and this value, if I see, I get it as 0030, fine, 0030, and J value is said to be 3C. J value is said to be 3C. Now this indirect addressing no ND, I'm going to use a format 3 because plus sign is there, so it is always format 3. Format 3 when 1 2 3 4 5 6 1 2 3, that is NIX BPE, and then obviously my 4 and then my last 4 has come. Okay, so when I am doing this, I know that @ symbol has been used. Which symbol has been used? @ symbol has been used. So സാധാരണ നമ്മൾ എഴുതുവാണെങ്കിൽ 0030 എന്ന് പറഞ്ഞാൽ ഈ അഡ്രസ് ലൊക്കേഷൻ ആണ്, and this address location is always in hexadecimal value. Please remember, address location is always in hexadecimal value. But ഇവിടെ direct ആയിട്ട് immediate ആയിട്ട് തന്ന values are all in to the base 10, which has to be converted to the base 16. Okay, അവിടെ മാത്രമേ conversion ചെയ്യത്തുള്ളൂ. But if you have a variable which is acting as a label, and അതിന്റെ corresponding location count in the value എപ്പോഴും hexadecimal ആയിരിക്കും, so you don't have to do any conversion. You can write directly the value 0030. Okay, so how do we go about it? നമ്മളത് എങ്ങനെയാണ് നമ്മൾ ചെയ്യുന്നത്? ഇത് ചെയ്യാൻ വേണ്ടി you have to find the difference. You have to find the difference. So return address എന്ന് പറയുമ്പം